Okay, so here we have a classic distance, rate, time problem using a linear equation, and it's the old two trains leaving a station at the same time. So we've got one heading west and one heading east. Okay, so we've got, if we have both of the trains starting at the same point, one is heading westbound, the other is heading eastbound. Okay, the westbound train is traveling 10 miles per hour faster than the eastbound train. So if the rate of the eastbound train is x, then that means that our westbound train is traveling x plus 10 miles per hour faster. Okay? If the two trains are 600 miles apart, after 3 hours, what is the rate of the westbound train? Well, let's set up a little table here. This is how I like to do these problems. So we have distance, rate, and time. Okay, so the distance traveled total is 600 miles, but we don't know what each of them traveled. We just know that in total they traveled 600 miles. The rate of the westbound train, so we'll call the top one the westbound train. The westbound train was x plus 10. And the eastbound train was x. And the time for both of them was 3 hours. So they each traveled for 3 hours. The westbound train traveled x plus 10, the eastbound train traveled x, and they traveled a total of 600 miles. So that means that rate times time, okay, so the rate times time has to equal the distance. And we know that this one traveled for 3 hours at x plus 10. The eastbound train traveled for 3 hours at rate x. Okay, and we're going to add those two together to equal 600 miles total. So here's how I would set this up. Take the westbound train, 3 times x plus 10, and then add the eastbound train, 3 times x, and set that equal to 600. Now it's just a matter of solving for x, which is the rate of the eastbound train. Eventually we will have to find the rate of the westbound train, but we'll start with finding the rate of the eastbound train since that's x. So 3x plus 30 plus 3x equals 600. Combine like terms, so I'm going to move my equation up here. That gives me 6x plus 30 equals 600. Subtract 30 from both sides. So 6x equals 570. Divide both sides by 6. Okay, so if I divide both sides by 6, that gives me x equals 95. Okay, I'm going to verify that on a calculator really quick. So we've got 570 divided by 6 is equal to 95. So x equals 95 miles per hour. And that's for our eastbound train. So our westbound train, remember, was x plus 10. So that would be a total of 105 miles per hour for our westbound train. Okay, and remember, we can verify this by multiplying each of those by 3 because they both traveled for 3 hours, Okay, so if I multiply x by 3, I get 285. So the eastbound train traveled 285 miles. The westbound train, 105 times 3, traveled for 315 miles. So that means that total we get 600 miles, which is what we had in the original part of the problem. 600 miles after 3 hours. That's how far apart they were. So our final answer, though, for what we were asked originally is 105 miles per hour is the rate of the westbound train.